Hello, welcome to Chapter 6, Section 4, Factoring Polynomials. Doing the problems on page 433 in the textbook. Problems 4, 5, 6, 7, 8, and 9. There's a lot of them in this section. Lots of practice. So we're going to factor by grouping. If you want to do it with the parentheses and reverse distribution, you go for it. I'm going to use the multiplication chart. I want to make a couple of reminders to myself. Always check if there is a greatest common factor. And also, some of these, especially if they have subtractions in them, not all of them are going to have subtractions in them. Actually, all of these do, but you saw one I did earlier didn't. Some of them might have difference of two squares in them. Okay, so try to remember the difference of two squares, because I know that Dr. Berger likes to throw that in with these problems. Okay, let's go. So I'm going to set up my multiplication chart. I'll put x to the third power here, x to the second power here, negative x, negative 1 here. 1, 2, 3, 4, 1, 2, 3, 4. Let's factor across the top row. I have x to the second power. That leaves the other x and a 1. X to the second times x is x cubed. X to the second times 1 is x squared. Cool. What do these two have in common? Well, the only thing it has in common is a negative 1. Negative 1 times x is negative x, and negative 1 times 1 is negative 1. So far, what I've got is x plus 1 times x squared subtract 1. All right, now, you should be on the lookout for this. I said x squared subtract 1. X to the second power, x squared, that's a perfect square. Subtract means difference. Is this the difference of two squares? Yes, because 1 is also a perfect square. It's 1 times 1. So this becomes x plus 1 times x plus 1 times x minus 1. For me, you can leave it that way. But some teachers are going to say, hey, look, let's clean this up a little bit. I've got x plus 1 times x plus 1, so you can actually write it like this. I'm okay with either one of these. I'm fine. It's just that I just want to prepare you in case your teacher next year says, no, do it this way. All right, let's do this one. I'm going to set up my multiplication chart. I have x to the third, 5x squared, negative 4x, and negative 20. What do these two have in common? They both have an x squared. That left the other x and a 5. What do these two have in common? This is negative 4 times x, so I have to put a negative 4 here. This is negative 4 times 5 gives me negative 20. So I get x plus 5 times x to the second power, or x squared, subtract. If that last thing I'm going to write here is a perfect square, I've got the difference of two squares, and guess what? It is. So my final factored form is x plus 5 times x plus 2 times x subtract 2. And I haven't said this yet. I should mention this. The order doesn't matter. So if you write x plus 2 times x plus 5 times x minus 2, that's cool too. Also, I wasn't sure how much space I was going to need. That's why I made 3 sheets of paper for this one. All right. So I'll draw big because I got the room. 8x to the third power, 4x to the second power. That and that. Negative 2x, negative 1. That and that. Go across the top. The common factor is 4x squared. That leaves the other x and a 1. 4x squared times, 2x. Good thing I caught that. 4x squared times 2x, 4 times 2 is 8, and x squared times x is x cubed. 4x squared times 1 is 4x squared. So I'm remultiplying to check it. What do these two have in common? The only thing they have in common is a negative 1. and remultiply. Negative 1 times 2x is negative 2x. Negative 1 times 1 is negative 1. So I get 4x squared subtract 1 times 2x plus 1. Now again, I got to check for difference of two squares. I have a subtraction. 4 is a perfect square. X squared is a perfect square. 1 is a perfect square, so I can factor this. This is 2x plus 1 times 2x minus 1. And then, of course, I got this left over, 2x plus 1. This is okay. Because these two are the same, you could also write it like this. 2x plus 1, and I've got two of them squared, times 2x minus 1. Problem number 7. Before I write my multiplication chart, I noticed something that I checked with the previous problems, or at least I wrote it here, but now I got to deal with it. I have a common factor of 2. So I have 2 times x cubed subtract x squared subtract 4x plus 4. So I've got my common factor of 2 there. Now I'm going to factor the remaining polynomial by grouping. X cubed, negative x squared, negative 4x, and 4. And by the way, I notice that if I've got a negative here, but no negative here, that means I'm going to have negative times negative equals positive. So be aware of that. This is x squared, leaving the other x and a negative 1. This is going to give me a 4, but like I just said, it's actually negative 4. Negative 4 times x is negative 4x, and negative 4 times negative 1 is positive 4. So I get x squared subtract 4 times x minus 1. But wait, don't forget the 2. Now let's check to see if I can keep factoring. And here's another clue to let you know if you should check it. Every single time when I had x to the second power, x to the second power, where am I at? X to the second power, x to the second power, I need to check to see if I can continue factoring that. And one more time, this is x squared subtract 4, which is the difference of two squares. So my final answer is 2 times x plus 2, oops, I messed that up, x minus 2 times x minus 1. Sorry, that's a subtract. That's why I should have waited till I was done writing it instead of saying it. All right. 2 more here. Do I have a common factor? I got 2, 3, 2, 3. No, I don't have a common factor. I have x's, but I don't have an x here. So, good thing I checked my common factor, or for a greatest common factor. 2x cubed negative 3x squared negative 2x and positive 3. So like I said with the last one, or one of the last ones, if these two are negative and that's positive, that means that these terms on the outside are going to be negative. What do these two have in common across the top? They both have x to the second power. That leaves a 2x and a negative 3. What do these two have in common? They don't have anything in common. Here's a 2, here's an x, there's a 3. So this is where I got to think about factoring out a common 1. But that doesn't work yet. It's good. It's not good enough yet. Because a positive times a positive is not a negative. Same thing, positive times negative should be a negative, not a positive. So like I said, this actually needs to be negative 1. Now everything works. And I get 2x subtract 3, that's good, times x squared subtract 1. What did I tell you? If I see x to the second power, check to see if you've got the difference of two squares. And I do. 2x subtract 3 times x plus 1 times x minus 1. All right, let's take care of one more here. Do I have a greatest common factor? I got 12, 3, 24, and 6. Yes. My GCF is going to be 3. So I have 3 times 4x squared plus 1x, subtract 8x, subtract 2. Now, this problem is way different than the other problems that we have. Have you noticed it yet? Pause it. Okay, now maybe you're back. This is not simplified. This is actually 3x subtract 24x. This should actually be negative 21x, which would have made this negative 7x, because times 3 would have been negative 21. So what we're doing with this problem is all the other ones were cubics. This is still a quadratic. So all the other, what we're doing with this problem is basically using the area model that we learned in the previous section, kind of. Here's my multiplication chart. 4x squared, x, negative 8x, negative 2. Across the top, I have a common factor of x. That leaves 4 times the other x and 1. Across the bottom, I have a common factor of negative 2. Negative 2 times 4x is negative 8x, and negative 2 times 1 is negative 2. So my factors are x subtract 2 times 4x plus 1. Neither of these has x to the second power, so I don't have to worry about the difference of 2 squares. This is completely factored, except, don't forget the 3. All right, we'll see you in the next video.